Well, thank you for everyone for attending this afternoon. I appreciate you're probably all busy people, and we do appreciate your support and your attendance on these webinars that we perform. Today's webinar, as you can see on screen, is just to go over how we see the fundamentals of product and quality testing. My name is Gavin Hall, and I'll introduce myself formally in a second. So let's continue. So important bit of sort of admin information for you all. This webinar will be recorded. Everyone is muted to keep me sane. Stop any questions during the presentation. You can use the chat function by all means. Please fill in your questions, and if we have time at the end, we will review those. And if we don't have time, we will come back to you, take note of the question, and answer you more formally. We can share the presentation slides, which we'll send via email, and the recording will, once it's been processed, be available on our website and our YouTube channel. As I say, my name is Gavin Hall. I am product specialist with Amatec STC. I have 35 years in the test and service industry, and the last 16 years predominantly I've worked for Lloyd Instruments Amatec STC and in the product and materials test sectors. So a little bit of agenda today. What do we test? What are we looking for? We'll look at how we can help, how Amatec STC can help. What should we consider for successful testing? We'll have a quick equipment overview of the Chatillon DFG3 force gauge and the TCM test stand, some typical applications, some additional test options, and obviously if we have time and if you have any questions. So, why do we test? Let's consider why do we test. So, as a manufacturer or supplier of product, be it final end use or component parts to a larger solution, they ideally have and are held to a responsibility to prove the following factors. A design criteria has been met, and most cases is hopefully exceeded. The safety elements of that product's design or its operation have been considered and are to be tested. Quite clearly, the functionality or operation of a product is checked to its conformance, is performing as expected. Consider the lifespan and longevity of a product. So long-term testing or repeat testing after a period of use. So if we consider, some people call this the bathtub curve, product and quality testing, failure rates are important and can be measured as MTBF, mean time before failure. So if we look at this graph, we've got a failure rate up the left-hand axis and a time or a lifespan cycle across the bottom axis. And the dotted line indicates the number of product failures. So typically with a product design, we start off with R&D, research and design, pre-production phase. And during that cycle, it's a critical part of the product's testing phase, because at this time, obviously we're looking at how it was designed and has it met its design criteria, its need for existing. Accurate testing should root out any design errors, prove the product specification if there is one, hopefully there is, and the trend of the failure is hopefully downwards. And then we move on to the manufacture and working life of a product. So in this phase, it's checking quality of build and quality of the manufacture process. Obviously key to some large manufacturing sites or quality departments, and the trend of failure should hopefully flatten out. So most of the glitches or the adjustments have done in the R&D phase. And then we move on to the failure or service cycle. So the aging of a product or a period of use can result in a sudden or a gradual failure. So the work that was done during the R&D phase can be fundamental in predicting this phase. But obviously a product needs to be used needs to have a life cycle to know its failure rate or its condition after a period of use. And we typically see a trend of failure will start to rise again. So from our point of view, using a test machine and or analytical software along with it can help identify key performance parts in a product's design and manufacture, and data that's gathered can be fed into calculations to determine the mean time before failure parameters. And then from a thorough and repeated round of testing, the data can be fed back into that process and help a company identify and improve the following factors. So critical design failures or the lifespan of a product. Ultimately, companies are held to their quality and their design of a particular product, and any failures resulting from that can have quite drastic consequences on use or people buying that product. Supplier quality issues, so anyone using raw materials can check the quality of those materials when processed into component elements. Any failures in that manufacturing process itself, so parts can be taken from a line or parts can be taken at certain functions during the production process. And then that information could be fed back in to improve that process of manufacture. Obviously, cost savings are key. We all know prices are rising for certain materials, cost of living, everything else. Key process improvements, and obviously requirement for rework action. If you have a serious fundamental error, how much is it going to cost to put it right? Is it a manufacturing process? Is it a machinery part that needs replacing, or is it a combination of several elements? And then information could be used to work out warranty periods of products and potential limitations of use. So if you're trying to put a specification around a product or how it should be used or what it shouldn't be used for, the testing can help identify that. And then from all that, service cycles of products, and importantly, revenue generation for your company or the company that's manufacturing that process can be calculated as service costs. So how should we consider successful testing? What are we looking for? So before any acquisition of equipment can be considered, we should review the following points. Identify the requirements for testing a product, predominantly safety, its performance, lifespan, and costing. What are the key measurements to be taken during the testing process? So is it operational limits? Is it stress or fatigue? Are we looking at pushing that product to its design limits? Analytical measurements, so during its time, key measurements can be taken. Stress or strain, or operations of the product can be simulated using the equipment. Simply simulate the operation of the product. So is it fit for purpose as it's going into an end user? And quite importantly, a defined product specification from which performance outcomes and measurable results can be referenced. We normally, when we discuss with customers, we ask for a product specification. Obviously, it's important to understand the customer's needs and the customer's expectations from one of our machine provisions. And we strive to understand how the customer is looking to test that product. Ideally, to help you specify a machine, it's nice to know the possible forces involved, the physical size of the specimen. This helps aid the choice of equipment and grips to hold the product. Sounds pretty obvious, but we have certain specifications for our machine, so we try and sort of contract out with an end user what they actually need. It's quite important because it can be overlooked. And ideally a test actual specification. So if this product is being tested in a certain way, it has to be tested in a particular order of process, then we normally ask for a test method or a statement of test requirement. So how do we identify testing requirements and results? As we say, we define a defined test method potentially. Now this could be an in-house product specification that highlights the operational functions and identifies the test limits. Test limits the speeds and the results required to successfully measure performance and quality of manufacture. A test standard, there are a number of organizations, ASTM, just an example, EN, ISO, TAPI, and many, many more. These are usually papers that have been approved through usually gauge R&R studies, round robin studies, and are quite a read. They can be quite involved, but they do cover the fundamentals of test requirements, limits, and things to be aware of through design. But in all honesty, it's usually a case of a combination of both to define the method. Hopefully, as design people, people understand the product that the product need they're putting it into, so they will have a good idea of how they need to test it as well. And another sounds obvious again, how will the sample be held during a test? What type of fixture or grip is needed? Obviously, our machines have a fixed area for testing the sample under. So a dimensional mechanical drawing is useful for us and also for the customer to provide, so there's an agreement in how the sample is going to fit on the machine. Again, reference to a test standard. Again, they may recommend a fixture or a particular method of handling, and they sometimes specify a grip method or a particular housing that's required to simulate the operation of the product. And how are the products actually going to be simulated in the real world? Is it being supplied to a larger assembly? So part of that gripping procedure could be a sub-assembly that part fits into. That may need to be simulated or produced to hold that sample while it's under test. So again, how do we define test limits and results? So what's the expected outcome of a product? The key considerations. So is it to be stressed to a fixed limit? And in our machines, normally that's traditionally a force, an extension, a height, or a period of time. Is it tested as part of a limit or failure or action point? So a break detected, a peak registered, or a change in the product's condition. And is the product is tested in its design form to check its functional operation. So has it got an expected recovery from a test period? Must it reach a certain size again or a certain force? Is it a long-term test to check the operational lifespan or the mean time before failure, which we spoke about earlier? And obviously key are what results are required. And these are usually in the form of a force or extension value. Again, from our machines, we can produce other results, stress and strain from dimensional sizes of the product. And are these to be referenced from a defined specification, a test standard, or functional performance of a product? So just a little bit about us. STC, Amatec STC. So we're an established global company with over 50 years of testing experience behind us. We make a range of product and materials test machines and analytical software. We specialize in analytical quality and performance testing of products. That's one of our key goals and key performance aspects. And we supply into many industries. As you can see, there's a list. I won't read them all out, but anyone who's in the manufacture, packaging, and medical would normally have a test machine as either a quality tool or a go no go style end of line product testing machine. We have a team of dedicated sales engineers and application specialists, and we can recommend and advise on equipment needs, application requirements, and test methods. And we have support of our friends through our global distributor network for sales and support. So, as I say, we specialize in many product quality and production line testing solutions. So a selection of our machines are shown below. So the Chatillon brand of machines, motorized test stand with a digital force gauge. We have a Chatillon CS machine with a touchscreen tablet, so a built-in computer to control the machine. And we have our Lloyd's materials testing LS series machine with its additional NextGen Plus software. So these are single column machines. We obviously make larger machines as well, but we're concentrating on the single columns today, and in focus on the Chatillon test stand today. So just a brief overview of the Chatillon force gauge and the TCM test stand. So it's a handheld gauge, can be used simply and freely in free space. Stores its results locally, can be used with software as well. So you can export those results back to the software. And it's usually well suited for product and quality testing. It's portable, it's lightweight. It can be moved around a factory or a lab quite easily. And we have two models of the DFS gauge, digital force gauge. So we have the E and the S. Again, all these specs are available on our website. But some key functional differences. So this is a simplified gauge, the DFE, and the DFS has a slightly higher spec and a few more functionality features. Again, all those can be read and seen on our data sheets from our website. So looking at the digital force gauge, we can make settings from the control of the gauge. It has an inbuilt menu, and within that menu, we can set up a complete test, and we could choose the force units, so we can do metric or imperial units. We can choose the polarity of the gauge, which direction force will be measured in, and we have a number of configurations for. We can do peak methods, load averaging. We can start and stop on certain functions, and we can store results within the gauge itself. The gauge can be used as a storage device for any results. And obviously there's a home screen display to give you the load and extension. If you marry that with the TCM test stand, so this is the motorized test stand. It has a front panel control as well. It can be controlled from a DFS gauge. It can be used standalone. Again, front panel controls determine the direction you go in. You can set the speed here and also start and stop a test from that front panel. So some very typical applications we get involved in the packaging industry. We can see we've got some typical fixtures, bottles and canisters, seals, carton crushing, form crushing, medical industry as well, needle insertion, sealing of medical packaging. We can do glide forces of syringes. So a lot of people, especially after the COVID pandemic that we had, a lot of medical companies were ramping up testing for that type of delivery, and blister pack sealing, so pill packs and packaging. So let's just look at a couple of typical applications. So this is a cap test. So we have a small bottle there with a fixed cap, and we're just looking to capture the peak force to take that cap off the specimen. The results could be required for an application reason or for safety reasons, manual handling reasons, if it's to be held in the hand and the cap is to be pulled off. And industries would include medical, pharmaceutical, packaging and cosmetic. We would use a generic grip at the bottom, and we would hold the sample while the machine is underway. And typically, I won't read through all of this, but this is how we would set the gauge. To do this, we are looking for a peak in this case. We're testing in newtons. We can set the test speed of the test stand, how fast we want to take that cap off. And you can see through use of the interface on the gauge, we can set all these parameters, and this will be stored as one of the test setups available to run within the gauge. And then we can actually set the sample ready to go. We tighten the grip up to hold the sample. As you can see, my colleague's hands there doing that. And once you're ready to go, it's simply a case of pressing the start button on the TCM. And you can see the gauge is being moved up by the test stand, and we are recording force on the gauge. And when the sample breaks or the detection is made, we can see that the test is over and we have recorded a force on the gauge. Another typical application, T-peel. So a T-peel is a delamination of two surfaces. Typically, it could be laminated or bonded. This could be required to check for product performance and application or lifespan. And again, adhesives, tapes, seals, medical, packaging, textile. We're using some self-tightening grips here because some samples can thin as they are put under tension. So these grips self-tighten. Again, a lot of information here, but again, the fundamental parts are we're pulling in tension again. Obviously, we're setting a speed. We're looking for a peak, but in this case, we're now looking for an average load as well. So we can set the gauge to monitor an average force over a period of, in this case, time. So we're going to test over 29 seconds in this case. Once the test is stopped, it will record that force. Sorry, record that force as an average and then stop. And it can be saved into the gauge quite simply. So the user interface again is used to set this all running. And then again, as you can see, the start button is pulled, and you can see that the sample is being peeled apart, and the average force is being recorded in the gauge to do that. Okay, so the sample is virtually peeled apart, and the machine returns back to zero. And the average peel force is shown on the screen there, 97.48 newtons. And we can zoom in and just have a look at the gauge. We can also, from this test, look at the peak force that was required to separate this product as well. You can see 124 newtons. So a dual aspect testing here in this gauge. And then we can see the results are stored, ready for review. And then finally, a top load test. So the aim of this test is to capture peak forces by compressing a specimen a fixed distance and checking for a load yield, so a drop in load or a failure in the product. And typically it's used to simulate the act of stacking multiple packaging or containers upon one another when being shipped or stored to see if they have the strength to resist that crushing or failure. Again, plastic bottling industry, the food and beverage, many liquid packaging containers. So we're using a simple platen here to compress the sample between. Another detailed setup, but fundamentally we're now operating in compression. Again, we're operating in newtons. We set a fixed speed for the machine to do this. We're looking for a compression peak this time, and we're also using the gauge to detect the break. So it's compression break, and it will actually actively look for a load drop during that compression movement. We're looking for a 90% drop in force, so the live force reading will drop by once it reaches the 90% value, the test will stop. We're using a trigger value to start, so we need to touch onto the sample to ensure that we are measuring it correctly. And we're going to have a fixed distance of 3 millimeters as a stop condition. So this is a secondary setting. The break detection should detect the sample yield, the specimen under test yielding, but we have the secondary condition just to stop the machine should any unexpected event happen. The sample doesn't have the strength to resist the compression. And then we're running that as well. So you can see the sample is placed very easily. You can imagine this on the end of a production line, sample after sample, go. Sample is tested. And the machine returns. And again, we can see that we have a force, a compressive break of 191 newtons. Okay, so those are just typical examples. As I say, many more do exist. We do have application notes on a lot of these things. So if anyone needs to see more examples of what the machines can do, please feel free to contact us. So additional test options. We also make external transducers. So these are force transducers, and we also do a torque transducer. So these actually attach externally to the digital force gauge, and basically expands the measurement and application ability of the gauges. We can also, if you have a smaller lightweight gauge, we can also use it with an external gauge to expand the testing range of that gauge. It will accept a larger capacity external force cell and treat it with the same measurement technique and accuracy. We have force test software. This is a bolt-on again to either the gauge or the gauge and the TCM test stand. And within this software, we have a database where you can store a variety of test methods for products and specimen types. We have a user interface, hopefully an intuitive user interface where you can test. You can select the direction. Are you doing a peel test or a friction test? If we're using the external torque cell, we can also use a torque measurement, so rotational forces rather than axial loading forces. We have a number of test parameters and select active results. So you can see we have a library of results down here. So we will plot a graph, and you can configure the software to post-test give you particular results, mark the graph, identify key areas of the test sample. And as you can see in this particular example, we've done a compression test, and we're looking for an average force. So the software will actually help you to calculate the average force, and it will give you the results at the bottom of the screen. And you can test product after product with this software as well. We have visual reports. So we have a built-in designer. So if you have a need to export that data, to report that data as a group of products or individual products, we can do that. You can add your own logos, you can add your own graphics, and really tailor the report to your own needs. Just an example of a standard report. As you can see, we have the results and statistics, so statistical analysis, and we can also export to such formats as Excel, CSV. So if you need to do any post-test analysis, redraw graphs, or send those results on to another software package in a particular format, we can cater for that need as well. Okay, that sort of concludes it. I hope you found it reasonably useful. I hope I've covered what I see as the fundamentals for testing. And I know it's tailored to the Chatillon product a little, but that's really the ideal product for the production testing. Simple, quick, and repeatable. So I'd welcome any questions or any feedback if you have. Thank you. Okay, see some questions coming in from a tria. How do you stop a test from running a DF3 with limits? I assume that you mean that's on a TCM test stand. The DFS is the real gauge to use with a TCM test stand that has better stop conditions. If you have a particular question on that, I can certainly help you. We can, if you drop me an email after this meeting. Kenneth is typing something. Let's see what Kenneth's question is. Okay, thank you, Kenneth. There is an ASCII mode in the gauge. Um, Sending commands to the test stand is something that's being developed, so we can send serial commands to the gauge and potentially the test stand going forward. This makes it a little bit more ideal for such things as PLC environments where you want an external computer control or overriding control to use the gauge as a piece part within a test procedure. So yes, there is an ASCII command set that can be sent to put the gauge in a certain mode, to retrieve change units, to retrieve particular data, start and stop the test. So yes, there are some things. I will all these will be available. We will be producing more documentation for the gauges when we launch the next phase. So please look out on the website. Lean will be working hard, I'm sure, to facilitate more information. So Calmet, can we analyze yield points, modules, etc. with Nexigen? This is we were actually using force test here, but yes, the force test software can will allow you to move in certain regions of the software. So you can see on screen here, we can actually have multiple ranges to detect peaks, and yeah, as I say, you can have multiple ones here. So if you have a particular peak here, we can analyze here, but we can also get values over here. So yes, it can be configured to give you multiple areas. And Dennis, how does the TCM measure extension? Well, the TCM, when it's connected to the force gauge, let's see if we've got a picture of that. So when it's in this format, or when it's mounted to the main frame, you can see probably on that graphic it's very small, but there is a force measurement, and below that there is an extension measurement. So there is an encoder in the test frame. It's going to pass that data back out to the force gauge in the form of inches or millimeters, so metric and imperial. And you can actually take readings from the gauge, and you can actually use stop conditions of extension to control that gauge and control the movement of the test stand. So not only can we move to a certain force, we can move to an extension. But this is the next phase of the product, as I say. We are waiting on a couple of things, but hopefully I can't give a particular time frame at the moment, but the next phase will introduce extension control on the TCM test stand. Did that answer your question, Dennis? Limited on the DFE. DFE will display extension. So and it's total extension. So from the start of a test, if you zero, you can get the total travel. What we can't do with the DFE is actually control the TCM test stand from the DFE. The DFS is the tool to use that. So if you want to drive to a limit or take results from that limit, it's a DFS force gauge you need. No problem. Is there anything else? As I say, I know these are very quick, these things, and it's not like being in front of someone. Oh, hang on, we have one here. Kenneth, again, thank you. Can it measure and compensate for its own? No, there is no compensation in this frame. The CS is the nearest competitive frame to this, and that does have deflection compensation. So you have to be aware that there will be an accuracy budget for the TCM when being controlled. So be careful on what type of application you're going after. Typically below 5 millimeters, if it's going to be a movement there, it would not be probably best for this type of machine if you're looking to measure extension from a product. Okay, if there is no more, I can be contacted anytime, and so can my colleagues. Obviously, please feel free to reach out to us We're happy to do some more demos with you on a one-to-one basis, or answer any application needs that you have. And we will be producing a lot more literature to come out to explain a lot of our capability for this particular product line. But I really appreciate your time, everybody, in taking time out of your busy schedules, and I hope you found it useful.